Hi everyone, in this video I'm going to show you how to find functional dependencies with this example and how to find a key for it, key for your relation. So let's start with attribute A. Now let's see, remember our rule here is not that one, here this one. So B depends on A, B is functionally dependent on A if each value of A is associated with exactly one value of B. Okay, so based on this rule, now we're going to find the functional dependencies, and from there we're going to find some keys. For example, let's start with A. For A, let's check for A and B. We're looking for whether B function depends on A. For value A, we have B here, and for value A, we have D. So that did not hold, and we cannot, so we know that B does not functionally depend on A. Now let's see A and C. For A, we have a Z here. For E, there's R, A, Z, E, R. So for so far, each value of A, there's exactly one value of C. And we come all the way down here, E, R, A, Z. So yes, we can say that C functionally depends on A. I'm going to write it here. Now let's go back and check for D. For A, W, E, there's W, that's fine. A is W, so for A, still the same value. For E is also still the same value. Now it breaks here because for now A, we have S, and for E, we also have an S. So it was holding up to this point, but after that, it did not hold because there's another value now for these values. So D does not depend on A. Let's look at E. For value A, we have Q. For value E, there is P. For A, now there is T. It has to hold for every row, but it doesn't hold. Now let's look at B. Attribute B. Let's look B to A. B, for value B, there's A. For value B, there's E. Doesn't hold. For B to C, for value B, there's Z. For value B, there's R. Does not hold. For value B, there's W. Value B, W. For value D is W. DW. And for F, the value is S. So yeah, for each unique value of B, there is exactly one value of D is associated with that. So we can say that D functionally depends on B. Let's see B and E. B, Q, B, P didn't work. Alright, let's see from C. For Z, there's A, ZA, ZA. For R, it's only E. So yeah, it does hold. I'm not gonna write it there for now, or actually I'm gonna write it. Let's write it C to A. So A depends on C, and then let's see C and B, B and C to B. For Z there's B. For R there's B. For Z there is D. It didn't hold because the value of Z is associated with two values of B. Let's look at D. For both R and Z there's W, but then it's also associated with values S. Did not hold. So now let's look at C and E. For Z there's Q. For R there's P. For Z there's T. Doesn't work. Alright, so let's look at the next one. From D, we have, can we determine A? For W, we have different values of A, so it doesn't hold. Same as B, same as C, same as E, so you cannot really determine anything from D, so nothing really functional depends on D. And for last table, so last attribute E, for Q there is A, for P there is E, for T there is A. Okay, so far it's fine. For Q it's E. So this one does not hold because for Q you have A and E. Therefore it does not hold for A. A does not function depend on E. Let's look at B. Q, B, PB, TD, QD. It breaks because we already have Q and B. Therefore, you cannot have Q and D. What about C? So you can have E, Q, E to C. So we're looking at Q and Z, P and R, T and Z. So far, it's okay. Q and R. No, didn't work. QW, PW, TW, fine. QW and TS. So here's the problem. T is associated with W, here T is associated with S. So you can't really determine, nothing functional depends on E. So one key that can be fine here is that you have A, B, and E. That way you can get A, determine A, B, C, D, and E. Right? It's full functional. Is it fully functional dependent? No, it's not. There's partial dependency here, right? Because right, because E only depends on E here. BC, sorry, D depends on B, and C depends on A. So, but this is how you can actually break tables down and try to come up with some functional dependencies, and then create your own keys for decomposed tables.